Hey guys, so in this video we're going to be looking at segment addition and the segment addition postulate. So let's get started looking at measuring segments. So the distance between 2 points A and B, so like we've got over here, is going to be written as the length of this line segment AB. And again, when we're talking about a segment, we're going to put the line above them. But if we're not talking about the segment, we're just talking about the length, then we're just going to write AB. So if we count from A to B over here, 1, 2, 3, 4 points. So just AB, how it's written over here without a line underneath it, is going to be 4. That means the length of AB is 4 units. So now we're going to look at congruent segments. So if two segments have the same length, so in this case AB is equal to CD, again, if we don't have the lines, it's talking about the length, so the length of AB is equal to the length of CD. So if we count over here, we can see AB is 4 still, and CD is also 4. So the distance between AB is the same as the distance between CD. We say that these segments are congruent, and that's a word you're going to be seeing a lot, okay? We're going to write that as the line segment AB is congruent, so an equal sign with a little squiggle on top. It's congruent to this line segment CD. So the two line segments are congruent if they have the same length. If we have an entire line from A to C, okay, the segment addition postulate just says that if we have this big line and it's split up into two smaller parts, okay, so this AB and BC, then we can say that the segment AC, okay, the segment AC, the distance of the segment AC can be written as this segment, the distance of that segment, so AB, plus the distance of that segment, BC. And again, we don't put the lines over top of them because we're talking about their lengths, not just the segments. So for instance, if this little part from A to B was 2 inches and the part from B to C was 6 inches, then the entire thing from A to C would be 8 because you'd be able to add them together. So now we can look at some examples. So we're going to use this diagram here for questions 1 and 2. So I'm going to show you how to do number 1. So if PQ is equal to 9, so we'll go ahead and do it on top here. If PQ is equal to 9, so from P to Q here is 9, and from Q to R is 28. So from Q to R over here is 28. Then we're trying to find the length from P to R, so the entire length from P to R. We know by the segment addition postulate up here that if we have the entire length, we can split it up into the smaller lengths added together. So we can say that from P to R is going to be the same as PQ plus QR. So we know that PQ, as we said here, is 9. We know that QR is 28. And then if we just add those two together, we're going to get 37. So that's going to be our answer for that one. So if we look at this now, I'll go ahead and erase what we've got over here. If we look at this for number 2, we can see that it tells us that QR is 17. So from there to there, Q to R is going to be 17. And then it tells us that PR is 21. So I'll go ahead and highlight the entire line is 21. So we're going to find PQ. So if we know that the entire length of the line is 21, this segment, and we know that this part of the length is 17, then whatever's left is going to have to be what goes here. So we're going to have to say that this PQ is going to be whatever's left. So it's going to be whatever we have for PR, and we're going to subtract this number, this QR, because whatever is left over after we subtract the 17 is going to be what gives us the length for PQ. So we're going to have 21 minus 17 if we look at the fact that PR is 21 and QR is 17. and that's going to give us 4. So the length for this one right here is going to be 4. So it's a little easier when we do just have numbers like that, but sometimes that's not going to be the case. We're going to have expressions instead of numbers for the lengths. So it tells us on number 3, from E to G is 71. Okay, and we're going to find the value of x. So we know that EG is going to be equal to the smaller segments, so EF and FG, so from here to here and here to here, added together by the segment addition postulate. So we know that EG is 71, tells us right up here, so we're going to replace EG with 71. We know that EF, we can see the length for EF is going to be this expression here. So we're going to put 8x minus 17, and we don't have to put that in parentheses, so let's not. It makes it a little more confusing, I think, sometimes. So this EF is going to be 8x minus 17 plus FG is going to be this 5x minus 3. Okay? Now we have something to work with where we can solve for x. So we'll add all the ones with x together on this side, and then we'll take the ones without x and add them together too and combine them. 8 plus 5 is going to give us 13x. Negative 17 minus 3 is going to give us minus 20. Then from there, we can solve. We'll add 20 to both sides because we need to get rid of the 20 first. So we're going to have 91 equals 13x. From there, we'll divide by 13, which is just going to give us that x is equal to 7. Since it just said to find the value of x, that's all we have to do for this problem. So now, looking at number 4, it tells us that TV, so again, the entire thing, is this 14x minus 8. And we're looking for TU. So our goal at the end is going to be to find what the length of TU is. So we know that TV, again, is going to be these two segments added together. So we've got from T to U plus U to V. It tells us that TV is this 14x minus 8 in the problem. From T to U, it says here, is this 9x plus 2. And then from U to V, it's just this 5. Now, again, we have something we can solve for. I'm going to go and take this plus 2 and plus 5 and add them together so that it's a little simpler. So we have 9x plus 7 on that side. And now we can go ahead and solve. And I'll go ahead and fix the fact that I put an equal sign instead of a minus sign. Okay, so we have this 14x minus 8 equals 9x plus 7. I'll go ahead and subtract the 14x to the other side. You can subtract the 9x if you'd rather. It doesn't matter which way you do it, you'll get the same answer. So that's going to cancel, giving us negative 8 equals 9 minus 14 is going to give us negative 5x on this side. We still have this plus 7. Now we need this 7 on the other side though, because we need the ones with x on one side and then ones without x on the other. So if we subtract 7 to the other side, we're going to get negative 15 equals negative 5x. And then we're going to divide by negative 5, giving us that x is equal to 3. So now that we have the x is equal to 3, we're going to look at this down at the bottom here to figure out what TU is. So we said that we need to figure out what TU is in order to solve the problem. Well, we said right up here, from T to U is 9x plus 2. So if we have 9x plus 2, we just have to replace x with this 3 because we know that's what the value of x is. And then if you just type that in your calculator, you're going to get 29. So from T to U is 29. And that's what we're looking for in that problem. So solve for x, put everything in where it needs to go, solve for x, and then plug the x value into whatever you're trying to look for. So if we look at number 5 now, it says if JL, so from J to L, the entire thing here, is 5x plus 2, we're looking for the length of JL. So we can go ahead and write down here that JL is 5x plus 2, and then we're going to solve that at the end. I'll mark off some space for it. So we know, again, that JL, so the whole thing is going to be JK, so this part plus the KL. JL, we wrote, is 5x plus 2. JK is 27. Then from K to L, we have 3x minus 1. Okay, so we just write that down. So if we want to simplify this a little bit, we can take the 27 minus 1 and get 26 plus 3x on this side. Now we just have to solve. So I'll go ahead and subtract the 3x this time, just to show you that it really doesn't matter which one you decide to switch to either side, as long as you have all the x's on one side and all the ones without x on the other. 5 minus 3x is going to give us 2x. We still have this plus 2 equals 26, and the 3x's cancel it out because 3x minus 3x is 0. If we subtract this 2, we're going to get this 2x equals 24. Then we'll divide by 2, giving us x is 12. But again, this is not telling us to solve for x, it's telling us to solve for JL. So now that we have the value of x, sorry, I keep pushing that button, but now that we have this value for x, we can take it and we can plug it in, we can substitute it. So we have 5 times x is 12, plus 2, and if we type that into a calculator, we are going to get 62. And so from J to L, the entire length is 62. So again, make an expression. The whole thing is going to be equal to the smaller parts added together. Plug in what you know, okay? And then solve for x, and if you need to, plug x in to the segment you're looking for. I want you to try number 6 on your own. So try this on your own. It's a little simpler because you are just looking for x. You're going to have the answer x equals some number, and that's going to be all you need to do. I want you to try number 7 on your own, but I'm going to set it up for you. So it tells you the SK, so from here to here, is this 13x minus 5, okay? From K to Y, so this little part here, is 2x plus 9. And then it tells you this entire thing, S to Y, is 36 minus x, okay? So again, when we do this, we know that the entire thing, so SY, is going to be the two smaller parts added together. XK, plus KY. If we plug in our numbers, we know that XY is 36 minus x. SK is 13x minus 5. And then KY is 2x plus 9. Okay? Combine like terms on either side. Solve for x. Once you get down here, you're going to get x equals some number. Okay, that's what you're going to put in here. But then once you get that, you're going to have to plug it in to each of these. So if you're going to look for SK, you're going to be looking for this 13x minus 5. You're going to plug it in for x, plug the whatever answer you got here in for x, see what you get. When you look for KY, you're going to do this 2x plus 9. Okay, you're going to plug in whatever you got here for x, see what number you get. And then you're going to do the same thing for SY, which is 36 minus x. Plug in whatever answer you got here, right here. Get a number, put those answers over here. Do that on your own. Next, we're going to be looking at the midpoint of a segment. So a midpoint of a segment is just a point that divides the segment perfectly into two congruent segments. So it divides the segment into half, where either side is exactly the same. They're congruent. So a line, a ray, or a segment that intersects the segment at its midpoint. So for example, here you can see this one hits it right at the midpoint, because B is the midpoint because it separates it into two equal parts. It's said to bisect the segment, and that's going to be called the segment bisector. So like I said, in the diagram to the left, point B is the midpoint of this line segment AC, because it cuts it perfectly in half. These little lines right here, this up and down line, means that they're the same length. That's what that means. So from A to B is the same from B to C, and since they're the same, they're congruent. So B splits this line segment into two congruent segments, meaning it's the midpoint. And then this line L here is the one that's going through this point, this midpoint, and that makes it the segment bisector by the definition above of this line segment AC. So in these examples, we know that since they are bisected and they have midpoints, and this is how we're looking at it, we know that the two sides are going to be the same because we have the word midpoint or bisect. If we have the words midpoint or bisect, so if we have the words midpoint or bisect, that means they're going to be the same on either side. That means both sides of the line segment are going to be congruent to one another. That means you're going to set those two sides equal to each other. You just put an equal sign in between them, okay? So Q here is the midpoint of PR, so it cuts it perfectly in half. So this side is the same as this side. That's why I've got the little marks. And if it has two marks, as long as they have the same number of little marks, that means they're the same. They're congruent. They're the same length. If they're the same or they're congruent, then you're going to set the two sides equal to each other. So you're going to write the one side, put an equal sign, write the other side. And it really is that simple. So for this example, we're looking for the value of x, so we don't have to plug it in or anything. So we just have to solve. I'll subtract the 7x to the other side, leaving this side with negative 16 equals negative 3x plus 2. I need the 2 to the other side since there's x's on this side but not this side, so we'll switch it to the other side. So negative 16 minus 2 is going to be negative 18 equals negative 3x. We need to make sure we divide by the negative 3x. We got to keep that negative sign. Okay, that's going to cancel, giving us x is equal to 6. And that's all you have to do. If you have the word midpoint or the word bisect, then the two segments are congruent to one another. You just set them equal to each other and solve. So this one, again, we have the word midpoint. So since h is the midpoint, these two sides, these two segments it created are the same. They're equal to each other. They're congruent. So we need 5x plus 2 is equal to 9x minus 10. Put the equal sign in between them and solve. I'll subtract the 5x. Okay, that's going to cancel out on this side. 2 equals 9 minus 5 is going to give us 4x's on this side. We still have this minus 10. We haven't done anything with it. But now we need it on the other side because we have the x's on this side and we need the ones without x on the other side. Okay, so it's going to cancel out on that side. 10 plus 2 is 12 equals 4x. Then if we divide by 4, that's going to give us that x is equal to 3. But this isn't telling us to solve for x. It's telling us to solve for gh. So from g to h here, it says it's 5x plus 2. So if we plug in this value 3 for x, 5 times 3 plus 2, and we type that in a calculator or do it in our heads, we're going to get 17. So the main thing to think about for these is that if you have the word midpoint or bisect, then the two different segments it creates here are the same. They're congruent. They have the same length. And so they're equal to one another because they're the same, so you're just going to put an equal sign in between them. I want you to do number 10 on your own. Again, you're going to put them equal to each other when you solve. You're going to get x equals some number, okay? But then it's telling you to find QS. So you need to say QS, okay? That's the entire thing. It's going to be equal to QR plus RS, which is going to give you 2x plus 16 plus this 5x minus 17. If you simplify that, we'll take the x's first. We'll have 7x's. And then 16 minus 17 is going to give us minus 1. And then you're just going to put in whatever you get for x right there. 7 times whatever you got here, whenever you set them equal to each other, minus 1. And you're going to tell me what that answer is. That's going to be your answer for the problem. I want you to try that one and number 11. I set up number 10 for you. I want you to try and do number 11 on your own without me setting it up. So let me know if you guys have any problems with any of these. And just remember that if you have an entire segment split into littler segments, then you can add the 2 smaller segments together to get the big segment. And then if you have anything that has a midpoint or the word bisect, if something bisects the segment, then the 2 segments created are the same or are congruent to each other, and you need to set the 2 sides equal to each other to solve. So let me know if you guys have any issues, and I will see you guys later. Have a good day. Bye.